Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najam and I hope you all are fine in every respect. So our today's session is for the O-level physics and our topic, which is already displayed on the screen. This is about the momentum. That's very important topic and this is, you can say a new topic is added in our syllabus. So this topic related with the momentum and related about the motion and about the quantity of the motion. So before starting the lecture, you people should know one thing. Watch this lecture completely, and second important thing, just like this video, share this video with other students to clear their concepts as well, and make sure note down all the content. And is there any confusion, so you may comment as well. I will reply. So let's start. Momentum. So basically, that we are talking about the momentum, the most importantly, that a force will change an object motion and it will make the object to accelerate. We know well one thing that acceleration is actually produced whenever velocity is changed, and it may make it change in its direction, and that particular direction may be changed because we are applying force on that particular body, and the effect of force which is applied on a body depends on two things. Number one, how big the force is, and number two, the time interval it acts for. So if we elaborate these two quotations, so we can say that the bigger the force, longer it acts for, and for the particular object, motion will be changed, and the impulse is actually produced. So basically, the criteria of the momentum depends upon two basic quantities. The first one is your mass, and the second one is your velocity. And here, about the concept of the mass and velocity, as per their product, we produce content of momentum. For example, this is a bowling court, and you know well one thing about this game, that once we applying force on the ball, it will move and strike the bills, or you can say bottles. So what can we do if we want to knock over more pins? Definitely, we will apply more force smartly. Then the ball will move accordingly and hit. And the most important point is that there is the change of force, there is a change of velocity as well. Because once we applying force on the ball and the velocity of the ball changes, and after the striking, the ball will transfer all of its force, all of its energy, and all of its velocity to the other body. So meanwhile, The concept is for the higher the velocity or heavier the ball, the same thing which relates about the momentum. So any object that has mass and velocity has momentum. That is why we compare the two particular, one is your heavier one and the other is your lighter one. So we know one thing, that the heavy object attain greater velocity. Is it possible? Or we can say that if it is possible, so it is very difficult to attain. Rather than that, this lighter object, just like this car, can attain the velocity about 100 kilometer per hour in few seconds as compared to this bus. So basically the concept of momentum and the concept of impulse is what? The momentum is the quantity of mass multiply velocity, or you can say the product of the mass and velocity. But about the impulse, that the change in an object momentum or the force acting on an object which is related with the time. Okay, so any object that has both mass and velocity has momentum, and this is the formula for the momentum. Momentum is equals to mass into velocity. Now we can easily calculate the momentum of different objects in different conditions. For example, 1 kg football traveling at 10 meter per second, so its momentum becomes 10 kilogram meter per second. 1,000 kilogram Ford Capri traveling at 30 meter per second, so you have to simply multiply 1,000 with the 30. A 20 gram pan being thrown across the room at 5 meter per second. So remember one thing, if we get the mass in grams, so we have to convert that mass into kilogram first. So 20 gram will be converted into kilogram by dividing it 1,000. So this is 0.02 kilogram, and then multiply with your 5 meter per second. You will get its velocity 5 meter per second along with the mass 0.02 kilogram. So then you will calculate its momentum. And same way as 70 kilogram jumper falling at 40 meter per second. So simply you have to multiply these two values. So you will get the particular momentum. So here if I write the definition of impulse for the assistance, that is the change in an object momentum or the force acting on an object with the time for which the force acts. This is exactly called impulse. Delta P is equals to F dot delta T. And the unit of impulse becomes Newton for the force and second for the time. So we can say that this is Newton second. N dot S. And about the momentum, this is actually quantity of motion present in a body with respect to their mass and velocity. So that is m dot v. And the unit becomes mass for kilogram meter second inverse. And here one important thing, that 1 Newton second is equals to 1 kilogram meter second inverse. Remember this thing. So we can say that momentum is the quantity of motion, and the change of momentum exactly called impulse. In easy words, we can define it in this parameter, right? So we are talking about one more thing, that the concept of the resultant force over momentum. So we know well one thing, that momentum is actually what? Mass into velocity. All right. And we know well one thing, that, for example, if I have this object having certain mass m, all right, and this body is at rest. But after some time, you are applying force in that particular body. So definitely it will start to move. Mass will remain same, but this time body in motion. So once body starting from rest and attains some motion, so definitely there is a change. There is a change in velocity. For example, if I say its initial velocity becomes u at rest and final velocity becomes v, so what do you think? That's change in velocity. That's a v minus u. So what do you think the momentum of the body at rest and the momentum of the body when it will be in motion, will it be same? Definitely not. So for example, if I say there is momentum p1 and there is momentum p2, p1 is your initial momentum and p2 is the final momentum, that means there is also a change in momentum. That's your p2 minus p1. So meanwhile, we can say that there is a change in momentum according to the condition that's related with the final momentum minus initial momentum. That is your P2 minus P1. So P1 momentum becomes mu and P2 momentum becomes mv. So if I try to mark these values, so I can say so I can write as mv minus mu. All right. Or delta P is equals to mv minus u, or delta P is equals to m delta v. So we can write the equation in terms of impulse. So if I want to play this equation as, since impulse of force is equals to change in momentum, change in momentum, and we can say that impulse is equals to force into time. So if I say impulse of force is equals to change in momentum, so change in momentum, that define delta P is equals to F into T, right? So we can compare these two equations for somehow. So if I say the change in momentum equals to m dot v, and change of momentum, that is we are talking about impulse. So we can say that if I mark 1 and if I mark it 2, compare equation 1 and 2, what we get? The change in momentum is equals to m delta v is equals to F into T. This is exactly what I say, the impulse and change in momentum both are same. Or you may write as m delta v is equals to F into T. This is multiplication, right? And as for that, we can say about the force. Force F is the resultant force which is given by F is equals to m delta V over T. And we know well one thing. What is exactly delta V? F is equals to m V minus U over T. Or if I multiply m, that's your mv minus mu over delta T. Change in time. I will mark as this. That's a change in time. Over here, you may put it down, the delta as well. Change in time. So this is exactly a relation. So the resultant force is actually the change in momentum per unit time. And this defines the force as a rate change of momentum. So we can say that a particular definition, that is, remember one thing, the definition of the force in terms of momentum, that force as the rate of change of momentum. Okay, so delta F is equals to delta P over delta T. This is exactly the equation for the force. But it is really just a different way of writing the more familiar equation. Which equation? The old one, familiar equation of the force, that is F is equals to ma, right? How? How? Because F is equals to m. What is exactly a? Delta v over t. Delta v over t, change in velocity over time. And we know that what is exactly change in velocity? V minus u over delta t. So again, we can make equation mv minus mu over delta t, the same impulse equation exactly that we did in the last slide. Look at this. There is no difference. There is no change at all. So we can say that indirectly we actually learned momentum, right? According to the second law of motion. So this is exactly the criteria. So remember that this equation. Okay. Now here one more thing, that is exactly the concept of collision in terms of momentum. What is collision exactly? Collision exactly what? It is the meeting of particles or of bodies in which each exerts a force upon the other. And on the behalf of the collision, we actually say that whenever a force acts on an object, its momentum changes, definitely. And at the same time, the momentum of the object causing the force also changes. So if one object gains momentum, then the other loses an equal amount of momentum. So this is exactly the concept of the principle of conservation of momentum. So whenever we try to elaborate the concept of momentum in terms of collision, so how can we elaborate it? Momentum in a collision. So remember this statement that whenever a force acts on an object, its momentum changes At the same time, the momentum of the object causing the force also changes. If one object gains momentum, then the other loses an equal amount of momentum, right? So, what is exactly the principle of the conservation of momentum? The total momentum is constant and does not change because of an interaction between bodies such as collision. We can say that momentum in an closed system is always remain conserved. So according to the criteria of equation, that is total momentum before collision must be equal to total momentum after collision. So this is exactly about law of conservation of momentum in terms of collision. So this is exactly, again, I'm repeating the momentum before and momentum after concept. It's like this, like the black car mass traveling with a velocity v, blue car is stationary, is at rest. But after that, the black car hits the blue car, causing it to move. So blue car now has momentum. Black car continues to move, but with the smaller velocity because rest of the velocity is actually transformed. So this is momentum before and momentum after concept. And this is the formula for momentum before equals to momentum after. So that is exactly the conservation of momentum. Like a car with a speed of 20 meters per second, mass is 800 kilogram, another car with a greater speed, with a heavier mass on collision, what should be the speed of the above green car, because new combined mass becomes 180, sorry, 1800. So according to the same concept of the momentum before and momentum after, that is exactly how we calculate the value of that particular car. So this kind of numerical analysis may ask in your exam. So remember the particular concept. Again, I'm repeating that the momentum before, that's your mv, the first body, with the mass and velocity of the other body equals to the mass and velocity after the momentum. Remember this equation. Okay. Another example, like a bullet or the gun recoil. Once we fire, so definitely there is a backward force which is applying on it, and this is because of the particular momentum, that's a 0.594. And remember that recoil of the gun is always negative because it is a backward force which is applied. Okay, and the minus sign indicates what? The traveling of the content in the opposite direction. So that's all about the concerned topic momentum, and I hope you all understand very well related to the topic. Okay, so that's enough for today. So if you may ask any question related about the topic, so you may comment on that and note down all the topical aspects that we have discussed. So meanwhile, inshallah, in the next session, we will cover another topic. So kindly like this video, share this video, and subscribe my channel if you still don't subscribe. And also press the bell icon to get the notification once I upload a new lecture video or any scientific innovative video. So take care. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.